Hello everyone, thanks for joining in. For today's lecture, this will be the topology. In that, we are using three routers, router 1, router 2 and router 3. In between router and router 2, we are using the subnet 192.168.12.0/24, and between router 2 and router 3, we are using 192.168.23.0/24. And for each router we are using one loopback, that is 1.1.1.1 for router 1, 2.2.2.2 for router 2, and 3.3.3.3 for router 3, right? And we will cover these four scenarios. So what we will do in the scenario 1, we will establish a EIGRP neighborship between router 1 and router 2, and we will block precedence value 6 at router 2, and we will verify that our EIGRP neighborship will be breakdown. So as we discussed in the previous lecture, that precedence value 6 is allocated to routing protocol, right? And in scenario 2, we will verify that actually we discuss that if we don't apply any marking on any traffic or any packet, then it goes with the best effort, right? So that part will verify in scenario 2. And in third scenario, suppose R1 is extended pinging R3 loopback IP with toss value 120, right? So how will we drop the same packet at R3? That part we will see in scenario 3. And in scenario 4, suppose any traffic at R2 coming from R1 as AF21 marking, right? And if we want to send the same traffic towards R3 as EF marking. So how will we do that? That part we will see in scenario 4, right? But before that, we want to cover the questions that we asked in the previous lecture, right? So first question is, suppose the IP precedence value is 3, then what will be the toss type of service value, right? So let's see. Here it's asking the toss value. So as we know that our toss is of 8 bits, right? And out of 8 bits, IP precedence uses only 3 bits, and the rest 5 bits is unused. So what we will do, we will convert this 3 decimal number into binary, so 011 and 0000, right? So when we'll convert this binary number into decimal, then we will get 1 2 4 8 16 32 64 128. Then 64 plus 32 is equal to 96. So here TOS value will be 96, right? Now second question is, if toss value is 135, then what will be the IP precedence value? Okay, so we discussed that IP precedence value only uses 3 bits out of 8 bits of TOS. So we will convert this decimal value into binary. So let's convert that. 10000 111. Okay, so it's 1247, and then this 128, then 135 will become, right? But IP precedence uses only 3 bits. So when we will convert this binary number into decimal, then we will get 4, right? Then here IP precedence value will be 4 for toss 135. Now third question is, if IP precedence value is 5, then what will be the class selector? See, in the last lectures, we discussed that out of 8 bits, we use 6 bits for DHCP and 2 bits for ECN, right? So to make compatibility with the IP precedence, we divided DHCP bits into two parts, class selector and drop probability. So the class selector and IP precedence is the same. I mean that the value of IP precedence will be the same as the class selector value. So here IP precedence value is 5. So class selector value will also be 5, right? Now question number 4 is, suppose toss value is 136, then what will be the DHCP? So as we know that out of 8 bits, DHCP uses only 6 bits, right? And 2 bits goes to ECN. So if we will convert this decimal number into binary, then we will get 1000100, right? 1 2 3 4 5 6 7 8. So 128 plus 8, that is 136, right? So 6 bit we will use. So when we will convert this binary number into decimal, then we will get 1 2 4 8 16 32. 32 plus 2, that is 34. Okay. So for 136 toss value, DSCP value will be 34. So we can verify from this table. So that is pre-decided. In this we can see all the marking. Okay, and as we discussed that the name of IP precedence value 0 is routine, 1 for priority, 2 for immediate, 3 for flash, 4 for flash override, 5 for critical, 6 for inter-network control, that one is routing protocol, and for 7 network control, that is L2 protocol. So here we need to keep remember that for value EF marking, the DSCP value is 46 and toss value is 184, and we know that EF is the best marking. And actually we can't purchase the CS6 and CS7, that's why EF is the best marking. And one more thing here, we can see that there are multiple marking here is given as only CS, right? Because in that DP value is 0, only CS value is 1, and all the rest DP value is 0. That's why here CS1 is given, right? And in CS7 we can see that DP value is 0 and all the CS value is 1. If we will convert these 3 bits into decimal, then we will get 7, right? That's why it's CS7. In CS6 we can see the most significant bit of CS is 1 and all the bits of DP is 0. So if we will convert 110 into decimal, then we will get CS6, right? So now we will move on the scenario part. So here first scenario is, so we will establish the EIGRP neighborship between R1 and R2. So let's configure the EIGRP between R1, R2 and R3. Actually, we are using EIGRP here because the timer is very less as compared to other routers. So we will get the output of neighborship immediately, right? That's why we are using EIGRP. And we will advertise all the interfaces with 0.0.0.0. Okay, no need to do one by one. So this is the topology as we discussed, and we already defined the interface IP. So here we can see for 1 by 0 we are using 192.168.12.1, and this is the one loopback for R1. And for R2, for 2 by 0 we are using 12.2, and for 1 by 0 we are using 23.2, and loopback 0 is 2222. And for R3, uh, for G1 by 0, sorry we haven't defined G1 by 0, IP address 192.168.23.255.255.255.0, no shutdown. So IP interface brief. So here 23.3 we are using for G1 by 0 and 3.3.3.3 as the loopback, right? So we will configure the EIGRP between R1, R2, R3. Let's configure that. Okay, so we can see here neighborship should be come up with R1 and R3. Yeah, now we will try to complete the scenario one. So here we can see that we will block a precedence value 6 so that neighborship will be dropped, right? So let's configure router 2 config T. We will take access list as an extended one so that we can use the protocol source and destination, right? So deny IP protocol source will be any, destination will be any, and the precedence value we will block is internet, that is CS6, right? Now we will allow the rest traffic 101 permit IP any, right? Now we will call this access list inside the interface in incoming direction. So our interface will be G2 by 0, G2 by 0 IP access group 101 in incoming direction, right? So we will see here that our neighborship will be breakdown. So IP EIGRP neighbors, it will take few seconds. See here neighborship breakdown with R1. So we can see here only neighborship with R3. Okay, when we will remove that access group from interface G2 by 0, the neighborship will come up. So IP EIGRP neighbors. See, we got the logs. So our first scenario is completed. Now we need to remove that access list. So no access list extended 101. Okay. Now our second scenario is, as we know that if you don't apply the marking on any traffic or any packet, then it goes via best effort, right? So we want to verify that. So suppose router 1 is pinging R2 IP, okay, R2 loopback IP. 2.2.2 repeat count is suppose 1 lakhs or 10 lakhs, okay. Now we will block the default CS0 value on R2, right? So we will see that our ping will be dropped, right? Let's create one access list to block the precedence value 0, 101. Here we will take the extended one that we discussed earlier, that so that we can define the protocol source and destination everything, right? Then IP source will be any, destination will be any, and our precedence value will be 0, right? Now we need to define the allow the rest traffic 101 permit source will be any, destination will be any, protocol IP. Now we need to call inside the interface G2 by 0 IP access group 101 and invert direction. See, now packet start dropping, that IP 2222 is unreachable. If we will remove this access list from the interface, then IP will start pinging, right? So we can verify, means or we can say we have verified that by default packet goes with best effort, right? If you don't apply any marking or any special treatment. Now we have to delete this access list from here. No IP access list extended 101. Okay, now we need to stop that pinging. Now our third scenario is, Suppose R1 is extended pinging R3 loopback IP with toss value 120, right? So how will we drop the same packet at R3? Suppose our scenario is if any traffic is coming with some marking, right? I'm just assuming that the marking is AF33 and we want to drop that traffic, then how will we do that? And if you want to verify that AF33, the toss value, if toss value is 120, then assured forwarding value will be 33. How can we verify that? So we can convert manually, or we can verify from the table. So toss value is 128, 120 here, and our assured forwarding value will be AF33, right? So we can do the practical. So here uh, I'm just starting pinging from R1 ping, hit enter. Protocol will be IP, target IP address will be 3333. Repeat count will be 1 lakhs so that we can verify the output. Datagram size will be 100, fine. Timeout, fine. 2 seconds extended command, CS. Source address will be loopback 0. Type of service by default is 0. That means best effort, but we want 120. And the rest thing will be by default. Okay. Now we will block AF33 at router 3. Now here also we need to create the access list 101, or we can say 110 extended one we need to take. Deny IP source will be any, destination will be any, and DHCP will be AF33. Okay, AF33 is there, right? Now rest traffic should be allow 110 permit IP source will be any, destination will be any. Okay, now we need to call this access group inside the interface. So interface is G1 by 0, right? Incoming interface G1 by 0. So interface G1 by 0 IP access group 110 incoming direction. Now see packet start dropping, right? When we will remove this access group, then packet will be start pinging. See, this IP is reachable now. Now we will move on the scenario 4. Suppose any traffic at R2 coming from R1 is AF21 and we want to send towards R3 as EF, right? Then how will we do that? Before implement that, we have to learn two things. First one is class map and second thing is policy map. As a class map is same as the route map that we use in our network uh, to classify the traffic, right? But policy map is used to specify the traffic, right? So we need to create the class map, so we can give any name. So we are giving the name as per our requirement, CM-AF21. Okay, we need to match the traffic that we are getting from router 1 with marking AF21, right? So match DHCP AF21. Okay, then we need to specify the traffic. So in policy map we can give any name, policy map, and PM-EF, because we want to send the traffic towards R3 as EF, right? Now here we'll call our class map in that is CM-AF1, and we need to set the DHCP marking that we want to send towards R3, right? That is EF. Okay, now this policy map we need to call inside the interface. So we can see outgoing interface of R2 towards R3 is G1 by 0, and here we will call this policy map with the command service policy. policy in the output direction, and the policy map name is pm-ef. Okay, so we will apply this command inside R2. Now we can verify the output here. So policy map interface G1 by 0. So here we can see that it will send the traffic with marking EF if it will get the traffic coming from R1 as AF21, right? So this was the scope for today. So I hope guys you have learned something new. So if you have any doubts, then please comment in the box. Till the next video, I am signing off. Take care.